Hello, everybody. Welcome to Happy Maths Hour with myself, Caroline Ainslie, and the amazing, wonderful Toni Beardon, who poo-poos me every time I say that.
Yes, poo-poo.
And today we're going to talk about, well, topology, but it's an introduction to topology. And today I am going to be asking lots of questions because Toni's been through this with me, and I've got my hat on of, oh my goodness, this is very, very fascinating and interesting, but oh my goodness, there's a lot of brain cells used up with this. So everybody switch on your brains. And as the wonderful Paul Erdos used to say, my brain is open. So open your brains. He didn't say my mind is open, he said my brain is open. He was Hungarian.
Well, this is easy stuff. It is very easy. And it's the sort of thing that teenagers can do in school. And it's a pity if they miss out on this, because it's giving a perspective of what maths is about, what it involves, and how and why it's useful, and what mathematicians do in solving problems that affect us all, that affect society. So
it's interesting. It's fascinating.
It's not
so when teenagers say, "Why bother?" It's because it's fascinating, and here's a perfect example.
Well, they're not ready to do it yet themselves, and the problem is that there's a lot. The problem is that there's a lot to learn, and you speed up as you get older. You don't learn. You learn fastest when you're very young, when you're about a year old. And then you don't learn as fast in school, surprisingly, but you actually, it depends on, well, maybe I'm wrong about that. You learn a lot of different things in school, and if it's a very good school, you learn the most important thing of all is how to learn,
and how to become a lifelong learner, how to be excited about learning,
and that you understand everything you do, because rote learning is useless, and a lot of school is unfortunately, because that's what school exams are about. Anyway, let's go on.
Right, so let's do it. Oh, here's my itchy bugs again.
Yes, and here is an Escher wood engraving of a Mobius strip, and you see that it's quite hard to know where the bugs are. Which face are they on? Are they on the outside or the inside? Are they on the top or the bottom? Well, we're going to do something more on the Mobius strip, and we're going to lead up into that, from that into topology. Now, here's my little ladybird that we looked at last week, and the ladybird is on a railway track, and the ladybird can go round and round that track, but only on that side, and so on that surface, and not on the side that's been shaded green, which I call green grass.
So the ladybird's going on the internal loop, like loop the loop, and if you go and then the other one is that really scary ride. Go on, the one on the outside of the loop.
Here we've got no twists, and so effectively, this ladybird is on the inside of a cylinder. Now here, this is a Mobius strip, and in order to make the Mobius strip, we change the points just where the ladybird is positioned now by twisting the strip through 180 degrees and joining the two ends. What we made was a Mobius strip, and now that's like changing the points on the railway track, and the ladybird can go from the railway that has got no green onto the green railway, all the way around that and back onto the other rail. So the ladybird can go over the entire inside and outside surface and keep going on round, over, across and along both surfaces. So that's a Mobius strip. Now, to recap on that, there's a cylinder, and by joining, if you just take a flat sheet and you just join it, you make a cylinder, and you just join one edge. But if before you join those edges, you do a twist, you make the Mobius strip. So that's what we just showed you with the ladybird. But you could join both edges Now imagine joining the top of the cylinder that you see to the bottom of the cylinder, and you make what we call a torus, but it's also known as a donut in common English. Okay. And on the right, you see something else, which is the natural thing to do if you think about what we did with the Mobius strip. But instead of joining the top and bottom of the cylinder, we did a twist before we joined them. We get something like that Klein bottle. So in a sense, the